Hello everyone, let's do more examples using the chain rule. So here we go. So first function is computative of e to the power minus 3x minus 3 to the power x. So be careful, the second term here is an exponential function using a base equal to 3. So I'm going to use the general exponential rule for that term. But the first term is a function inside a function. It's not just ex, it's e to the power of something. So I need to use the chain rule. So because derivative of ex is ex, if you have the derivative of e to the power of something, you're going to get e to the power of something again. But then what you need to add up is you need to multiply afterwards by the derivative of that something. And because the derivative of minus 3x is minus 3, the derivative of e to the power minus 3x is e to the power minus 3x times minus 3. And now for 3 to the power x, I just label my a to be 3. So the derivative of ax is ln of a times ax. So the derivative of 3x is ln of 3 times 3 to the power x. So just using that formula where a is equal to 3. And you can simplify if you wish. So next example, I have the function f of x, which is the product of x squared times e to the power minus 3x. And this is where things are going to start to become a little bit more complicated, because typically applying one rule of differentiation is not too challenging. It's when you have like more than one rule to apply that things can become a bit confusing. So here, what do we have? We don't have like a pure chain rule. It's not a function inside a function. Yes, we have minus x cubed inside e, but you cannot say your function is e to the power of something, because there's this x squared that multiplies the exponential term. So here initially, this is the product of two things. So this is initially a product rule. So I'm just going to label my first term, my u, as x squared, and the second term, the e to the power minus 3x, is going to be v. So u is x squared, v is e to the power minus 3x. So when you compute u prime, you just get basic stuff. So it's 2x. But if you want to differentiate e to the power of minus x cubed, now we have e to the power of some shit. So the derivative of e shit is e shit times shit prime. So the derivative of e to the minus x cubed will be e to the minus x cubed times the derivative of minus x cubed, and the derivative of minus x cubed is minus 3x squared. And now you just combine your formula using the product rule. So we remember it's u prime times v plus u times v prime. Okay, so you're applying your rules, so you just put the right things in the right spot and you get your final answer. And here the chain rule part was really within the computation of v prime only, but this question is initially a product rule. Okay, so you have to see this like when you're talking about this function from afar. Okay, so you see that this is the product of two terms. This function f is the product of two terms, and then you have like two questions now within the question, computing u prime and v prime. So one of them was basic, the other one was a chain rule. All right, next example, we have e to the power of x times sine of x. So here, inside the exponent, there's a product. But like when you think about this function like from afar, this function is really initially e to the power of something. Yes, that something is complicated, but we'll deal with that afterwards. So when you have e to the power of something, you just get the derivative of e to the something is e to the something again, so same term, but then afterwards you need to multiply by the derivative of that exponent. So here I took the time to write it down, because now when you look at the derivative of the exponent, and it's not because it's a chain rule that things change. I see a lot of 1 times cos, but the derivative of x times sine of x, it's the product of two things. So guess what? You have to use a product rule where the first term is going to be u, so x is going to be u, and the second term, sine of x, is going to be v. So then when you apply the formula, so you get u prime, derivative of x is just 1, times v, unchanged, plus u, which is x, times v prime, derivative of sine is cosine. So you get your final formula. So the derivative of e to the power x sine x is e to the power x sine x. Open the bracket down there, sine of x plus x cos of x, close the bracket. Okay, so you had to use a product rule. And I really like those two examples, B and C, done side by side, because to really see the distinction between when do you do a product rule first versus a chain rule first. So you really have to feel the algebraic structure. In example B, my function was the product of two terms. In example C, it was e to the power of something. And yes, we had a product inside the power, but it was not the first thing to address. Okay, so really you have to go layer by layer. More. Yes. So here for D, I have ln of x squared plus 1, so something inside the logarithmic function. And I have log base 3 of log base 3 of x. So here the a of that logarithmic term is 3. So for ln of something, so because we know ln of x is 1 over x, if you have ln of something, it's going to become 1 over that something, untouched. Remember, the thing in the box don't change, but it's afterward that you need to take into account that something. So afterwards, you multiply by the derivative of the inside. In this case, the derivative of x squared plus 1 is just 2x. And for log 3, because I know that log of a is 1 over ln a x, well, if you just use that formula where a is 3, you get that derivative of log 3 of x is 1 over ln 3. Be careful here, it's always ln in these formulas in the end, x. And you can simplify if you wish. The only thing to simplify here is combining the 2x with the 1 and writing it as 2x over x squared plus 1 minus ln of 3, minus 1 over ln of 3x. More. Okay, so for next example, we have that we want to compute the derivative of ln of a big expression, ln of x ex minus x plus 1. Yes, there's a lot of action in there, but initially, this function is the ln of something. So you have to use a chain rule first. So anything in the box goes down. So the derivative of ln of x ex minus x plus 1 is 1 over x ex minus x plus 1. And afterwards, you will multiply by the derivative of x ex minus x plus 1. And now here in this case, now the first term is a product rule, so you're going to use u and v, and then you're going to use the product rule, so you're going to get u prime, derivative of x is 1, times v, so times x, and then you're going to have plus u times v prime, so u is just x, and the derivative of ex is just ex again. So really that part here is the result of the product rule. So this part here is really the result of the product rule. I'm applying the product rule here. Okay, that's what I get. And then the derivative of minus x is minus 1, and the derivative of plus 1 is 0. And if you wish, you can simplify the expression afterwards. But again, here, it's very, very crucial to feel that initially this is a chain rule. So we have ln of something, so it becomes 1 over that something times that something prime. And inside that something, we have to use a product rule and some basic differentiation for minus x and plus 1. All right, let's do another example. So we have f of x, which is equal to x cubed plus ln of 4x minus the product of e to the power 1 minus 2 times ln of cosine. So a lot of things going on here. So the first term is just x cubed. So the derivative of x cubed will just become 3x squared. No problem there. Ln of 4x. Ln of 4x here is ln of something. So you get 1 over that 4x multiplied by the derivative of that 4x. And the derivative of 4x is just going to be 4 again, just 4, sorry. So, and that will simplify to 1 over x. So 4 over 4x just simplifies to 1 over x. But now for the second one, I have no choice to use a product rule. So we have u times v. So if I'm applying the rule here, and I'm just going to write it first, so I'm going to compute u prime times v plus u times v prime. And here, for both term, u prime and v prime, I'm going to need a chain rule here. The derivative of e to the power of 1 minus 2x is going to be e to the power minus 2 to the power of 1 minus 2x times the derivative of that power, which is just minus 2. And same thing for the derivative of ln of cos of x. It's going to become 1 over cos of x times the derivative of that cos, which is minus sine. And you can simplify if you want to. I don't want you to stress too much, but if you want to simplify, go ahead. But My advice normally here, if you just apply the chain rule and the product rule in the right order on a test, this is all we want to see. Okay. Anyways, I think for that video, that's enough examples. We'll just do more examples in the next video. That's it. That's all. Bye-bye. Hello everyone, and welcome back to the chain rule. So now we're just going to do more examples. So let's compute the derivative of f of x, which is sine of x minus x squared. So we have a formula inside the sine function. So since we remember that the derivative of sine of x is cosine of x, if you have derivative of sine of some shit, you'll get cos of that shit times shit prime. So here, derivative of sine of x minus x squared will become the cos of, so the sine turns into a cos, so it becomes cos of x minus x squared, and afterwards, you have to compute the derivative of the inside, and the derivative of the inside, derivative of x is just 1, and minus x squared is minus 2x. So very clean, short and sweet, chain rule. Next, we have the function of, which is cos of the square root of x squared plus 1. So here, the big function, the outside function, the outer layer of our problem is we have cosine of something. Yes, the something is x squared plus 1 to the power 1/2, but initially this is cosine. You have to really just do one rule at the time here. So if you have cos of something, it's going to become minus sine of that something. So cos of x squared plus 1 to the power 1/2 will become minus sine of x squared plus 1 to the power 1/2 times the derivative of the inside. So here, and I'm taking the time to write it down because the inside is complicated, we'll have to choose the correct formula. So what is the new question within the question here? We need to compute the derivative of x squared plus 1, all of that to the power 1/2. So here we have another chain rule where we're going to use the power rule to compute that derivative. So the 1/2 will fall up front. The new power will be 1/2 minus 1. And then you need to multiply because we have like something to the power 1/2. It will become 1/2 times that something, in this case, x squared plus 1, the power minus 1/2 times the derivative of that something. And here the box, the inside is not too difficult, so I can just write times 2x afterwards. And then if you wish to simplify, the 2x and the 1/2 will cancel each other. There's a minus 1 at the numerator that I'm keeping. So you get minus sine of x squared plus 1 to the power 1/2 times x, and the minus 1/2 will become 1/2 if you bring it down, and that's a square root. Okay, so you don't need to simplify. The only thing I would require you to simplify is I don't want to see any power with the minus 1, so I want to see minus 1/2, and you could leave it like this if the power was minus 1/2. But sometimes if you need to compare your solution, your answer with my solutions, well, typically since I have no life, okay, I will take the time to simplify my answer. All right, more. So next example, we have the derivative of cos of e to the power sine of x plus 1. So the plus 1 will go to 0. So first we have cos of something. The derivative of cos of something is minus sine of that something. So we're not changing the inside. We're just computing the derivative of cos and getting minus sine. And then afterwards, you need to multiply by the derivative of the inside of that cosine function, which is the derivative of e to the power of something. So here I'll have to use another chain rule. So since I know the derivative of ex is ex, if you have to differentiate e to the power of something, you're going to get e to the power of something times the derivative of that something. So we have to use another chain rule here to compute the derivative of e to the power sine of x. So e to the sine x is e to the sine x times cos, which is the derivative of sine. And if you want, you can remove the brackets here. It really does not matter if you simplify or not in this. All right, so let's finish with an example involving one of those brand new trig functions. So let's compute the derivative of sine of 2x times cosecant of 3x. So here we have a product rule first. Yay! So we have a product rule, so we're going to use a u prime, v prime, a u prime and v for labeling my two functions. So if u is sine of x, by using a little chain rule here, sine of 2x, sorry, the derivative will be cos of 2x times the inside derivative, so times 2. And if you have cosecant of 3x, so we know, you know, or you're learning that derivative of cosecant of x is minus cosecant of x minus cotangent of x. So if you have cosecant of 3x, you're going to get minus cosecant of 3x. So you're not changing what's inside times cosecant of 3x. And afterwards, be careful, there's only one inside derivative, even if there's two terms here. So afterwards, you multiply by the derivative of the box, okay, the function in the box. In this case, is just 3. And then I just apply my usual casual product rule. So it's u prime times v plus u times v prime. Okay, and just put the right function in the right spot. Simplify if you wish. Okay, you don't have to. What's really important here to understand is that initially this is a product rule. So I label my first term, in this case sine of 2x. I label my second term, in this case cosecant of 3x. I compute u prime and v prime using chain rule. So sine of something is cosine of that something times something prime. And cosecant of 3x becomes minus cosecant of 3x, cotangent of 3x, not changing the insides, times at the end 3, using my chain rule for that trig function. All right, for that section, actually, that's it. That's all. It's over, chain rule. You've learned all the rules. So basic rules, so basic formulas, basic rules, product rule, quotient rule, and now the chain rule. And of course, playing with all the rules together. Okay, all right. So for that big section, that's it. That's all. Bye-bye.